Aloha and welcome to week 13 of Science of the Sea. This is another week where we're going to go over a lot of information. Just take it one lecture at a time. I've got 7 of them this time. I'm going to try to keep them short again, but it's such interesting stuff. And these groups are what leads to vertebrates. It's what you see a whole lot of in the ocean, and I think you're going to really enjoy it and have fun this week. But don't start too late. Make sure you give yourself time to get through it all. So this first lecture is about Urochordata and Cephalochordata. These organisms are essentially the precursors to vertebrates. They are in the Chordata subphylum, but they're not really vertebrates. They are the bridge between invertebrates and vertebrates. They have very simple body plans with some of the main chordate traits. So what they have are a nerve cord, which is essentially the precursor to our spinal cord, and they have a notochord, which is, again, essentially the precursor to our spinal column, to our vertebrae. So that's what's important about this. This is a larval tunicate. We'll come back to tunicates in just a minute. But the familiar organisms, and you may not have ever heard of any of these, but lancets look similar to really simple or even larval fish. And tunicates, also known as sea squirts, honestly, the adult tunicates look to me more like sponges than they do something that would be in the chordate family. But if we go back and look at their larval form, then they look more like they have those vertebrate traits. These guys are generally very small. They're common in shallow coastal habitats. We don't always think of them. They go unnoticed most of the time. There are some species of tunicates that live around Hawaii, mostly around like the harbors and more shallow waters. Sea squirts and salps are both types of tunicates. Like I said, the larvae show the classic chordate traits. The adults generally lose those traits and are sessile, meaning they don't move, and sac-like. They look more like sponges, and they filter feed like a sponge would. The lancets in Cephalochordata are essentially more like small fish, but they don't have vertebra. They don't have a spinal cord. They have that notochord. They generally live partially buried in sand. They do have those chordate traits throughout their lives. And a lot of times when you see one, you might think it looks like a little tiny worm. They tend to be just a couple of inches long. They're very small. But these are the precursors to vertebrates evolutionarily. These guys have bilateral symmetry, an elongated, streamlined body. They have muscles along their body. They're kind of segmented, and that helps them to actually swim around a little bit. They don't swim, as well as a fish might, but they can move and swim around. You don't need to know all the parts of the body plan for the lancet, but I do want you to know the notochord and the dorsal nerve cord. Those are the 2 things that are most important here that I really want you to think about and remember. And this is essentially the parts of the notochord. You don't need to know the parts of the notochord. I just think it's interesting, all the different types of tissue that make up the notochord. These guys, again, don't have a backbone or true vertebrae, but they do have the nerve cord, which is the precursor to the spinal cord, and the notochord, which is the precursor to the spine. Feeding and movement. These guys, again, are filter feeders. Lancets and tunicates are both filter feeders. They have cilia at the front of their mouth that help to move that water into their mouth for filter feeding. They can swim, partly because they have those muscles, and they generally hang out partially buried in the sand. So why are we going over these guys? Why do they matter? They are the early precursors to chordates. They're the early evolutionary branches. Without these guys, we wouldn't have vertebrates. We wouldn't have us, which is kind of wild to think about. So these are kind of, again, the precursors. So these are simple organisms, but they're crucial to vertebrate evolution. Tunicates show temporary chordate traits. and lancets retain their chordate traits throughout life, and they help explain the origins of vertebrates. So that's it for this one, keeping it a little bit short, but those two groups are super important and essentially the origins of vertebrates. So next up, we're going to do just a quick overview of vertebrates.